All right. So we've got two triangles here, and we are asked to show that each side on this triangle is congruent to a side on this triangle. Congruent, when we're talking about sides, means that they're the same length. Congruence always means some type of sameness, but specifically what that means varies from thing to thing. So for side lengths, it's going to be the same length. And to do that, we're just going to have to use Pythagorean theorems, what we have right now. Now I'm not going to sit and do all the writing it out, but I'm just going to kind of do the math a little bit. So I've got 2 and 4, and just from past experience, that makes this square root of 20. And then down here, I've got 2 and 4, which makes this square root of 20. Here, I've got 3 and 3. And by the way, you don't have to draw these lines in. It's just I'm doing it as I count spaces or whatever, but it's not necessary. Let's see, so that gives us square root of 18. Right? And down here, 3 and 3, we've got square root of 18. And then down here for our last one, we've got 1 and 1, 2, 3, 4, 5. And that's going to be square root of 26 over here. And we got 1 and 1, 2, 3, 4, 5. 1 and 5. So square root of 26. Let's write out some statements about this, by the way. Let's write, we know that AC with a line over top, that means segment AC is congruent to A prime C prime. So segment A prime C prime, same length. We know that AB, that's this segment here, is congruent to A prime B prime. And put the line over top means we're naming a segment. If we don't have the line there, we're actually referring to the length of the segment, which would be this number, square root of 20, square root of 26, or so on. We know that AC, that's right here, is congruent to A prime C prime. Right? Oh, congruent to, forgot. Okay. And so what does that mean in terms of these two triangles? Well, it seems to suggest that they are the same somehow, right? And in fact, it means that the two triangles are congruent. But there's more to congruent triangles than just the side lengths being the same. We also have to know that the angles are all the same, right? So we would say that angle B here, which is up here, so that's this angle right here, is congruent to angle B prime. We'd write that like this, angle B prime. We know that angle A is congruent to angle A prime. Angle A is congruent to angle A prime. And finally, we know that angle, and I'm going to put some markings here. If two angles are congruent, we mark them with the same number of little arcs. So like B prime and B were marked with a single arc. A and A prime are both marked with double arcs. And that's a symbol, a marking we put on the diagram to tell us that the sides are the same, or the angles are the same measure. And then down here, we've got that angle C is congruent to angle C prime. So I'm going to put 3 marks on C, and I'm going to put 3 marks on C prime. Oh, by the way, just to toss this in there, when the side lengths are the same, I could mark that as with 3 tick marks, 3 tick marks here, 2 tick marks, 2 tick marks, single tick mark, single tick mark. So if two segments have like these little markings that match, it also means that they are congruent. So we have several statements here that the triangles have 3 pairs of matching sides and that they have 3 pairs of matching angles, all congruent. And that's what it means for two triangles to be congruent. It means that every side up here has a matching side down here that are the same length, and every angle up here has a matching angle down here. And when we talk about angles being congruent, we mean that they are the same size, meaning that they are, as an angle opens up, that's how far open an angle is that determines its size. So that means that the two angles are open up by the same amount. I think that's about it. This basically covers our definition for triangle congruence. One thing you want to start thinking about is like what order do they come in? So for example, with these, is it possible to have these two triangles congruent where, say, like the sides all match and say the angles all match, but say they're in a different order? Would it be possible for angle C to be congruent to A prime, and A to be congruent to B prime, and C to be, or B to be congruent to C prime, or something like that? Is that possible? Could that happen? Or does it have to be in a particular order? So something to think about. We'll look into that more later, I'm sure.